Hello everyone, welcome back to my channel. Today let us learn about Dalton's atomic theory. John Dalton is an English chemist, physicist and meteorologist who was born in 1766. He introduced atomic theory in chemistry. So let us look at some of the postulates of Dalton's theory. Atoms are indivisible. That is, they are fundamental units of matter. And the second postulate is that atoms can neither be created, destroyed, nor divided into simpler or smaller particles. Next, moving ahead, atoms of same element are identical. That is, all atoms of given element have same size, mass, and other properties. So, for example, we can take sodium as an example. Sodium atomic number is 11 and its atomic mass is 23 units, 23U, that is 23 atomic mass unit. And the size of the atom is 100 picometer, or what we call the radius of the sodium atom is 100 picometer. So it means that all the atoms of sodium will be having 23U as its mass and 100 picometer. And also, if we talk about some of its properties, then talking about its chemical property, it is always violent with respect to air and water. So as we all know that they react very vigorously and violently in presence of water, and they are highly exothermic reaction. Similarly, if you talk about physical properties, we know it's one of the only metal which is soft apart from potassium and lithium. Sodium is one of the metal which is soft and can be easily cut with a knife. So this is applicable to all the sodium atoms. Okay, now moving ahead with the next postulate, atoms of different elements are different. So if I compare sodium with sulfur, sulfur atomic mass is 16, sorry, atomic number is 16, sodium atomic number is 11, and sodium size is 100 picometer and sulfur is, sorry guys, sodium is 166 picometer and sulfur is 100 picometer. And when we talk about its mass, sodium is having 23 grams. That's one atom of sodium weighs 23 atomic mass unit, whereas sulfur weighs 32 atomic mass unit. So that, what is it meaning? It means that atoms of different elements have different size, mass and their properties. Similarly, if you talk about property, sulfur is a non-metal, sodium is a metal. Sodium is having a beautiful metallic color, whereas sulfur is having a vibrant yellow color. So that means that because there are different atoms, their properties also will vary and their mass will vary and the size will vary. So all this was understood by Dalton and it was given as a postulate. Now the last one, atoms of different elements combine in the ratio of small whole numbers to form compounds. So as we know, suppose I take water. Okay, so if I talk about water as a compound, then what is it mainly made up of? It is made up of two atoms, that is hydrogen and oxygen. And the ratio by atoms is going to be 2 is to 1. That is, there are two atoms of hydrogen and one atom of oxygen. And this is always constant. Okay, and it is always irrespective of the source of water, whether we're talking about river, pond, lake, or well, or any other source of water. The ratio of hydrogen and oxygen by number of atoms is 2 is to 1. Similarly, the ratio of hydrogen and oxygen with respect to the mass is going to be 1 is to 8. Okay, so hydrogen is 1 atomic mass unit and oxygen is 8 atomic mass unit. So this is again constant. Now what did Dalton's theory explain here is that atoms of different elements always combine in a fixed ratio to give rise to compounds, and this number is always a small whole number. We never expect atoms to combine in terms of a larger number like 50 or 60 atoms. We've never seen like that. We are always looking at compounds which are having very very small ratio, like HCl. If you take, it's one atom of hydrogen and one atom of chlorine. Similarly, if you talk about Na2CO3 ionic compound, then it is two atoms of sodium, one atom of carbon, three atoms of oxygen. So this ratio of numbers is always smaller whole numbers. Okay, so these were some of the postulates given by Dalton theory, and based on them there are certain merits of Dalton's atomic theory. So Dalton was a scientist who was successfully able to explain that so the atoms, okay, they are indivisible, and again atoms of same elements are similar in properties, atoms of different elements are different in their properties and mass and of course its size. And this led to the explanation of some of the laws, which is called as law of chemical combination. So the two most important law of chemical combination is going to be law of conservation of mass and law of constant proportion. So this I will be dealing in the next video. Thank you so much.